So chapter 14, we start getting into inheritance. Inheritance is just passing parts of a class down to another class. So it's like a parent to a child, kind of like when we did the HTML, CSS parts of it. We had parent classes and children classes, or elements and stuff like that. So that's kind of what this is going to be doing for inheritance in C#. Is you'll have a parent class, which is considered a base class, and then you'll have a dependent class, which is the children class. So objectives: use any features of inheritance that are presented in this chapter as you develop classes for your applications. Explain how inheritance is used within the .NET classes and how you can use it in your own classes. Explain why you might want to override toString, equals, and get hash code methods of the object class as you develop the code for a new class. Describe the use of protected and virtual access modifiers for the members of the class. Describe the use of polymorphism, and describe the use of type of class. Describe the use of explicit casting when working with the objects of a base class and a derived class, and distinguish between an abstract class and a sealed class. I'm not going to cover all these today. I'm going to just kind of skip through this a little bit. I don't like how they have this PowerPoint set up for this. So I'll kind of skip over some stuff here and there, touch on the important things, and then we'll come back and talk about some of them probably tomorrow or later in the week. Maybe later in the week as we get going. That way we can get both lectures out of the way and then give you guys plenty of lab time to work on these. I said there's only 3 labs for this chapter, and I'm going to kind of show you how to code 2 of them, so it shouldn't be too bad. The Pokemon one will be a little bit of a challenge. I'll probably have to show you how to use images and stuff like that in your forms. So, but how inheritance works: inheritance is used nonstop through these forms and applications we're creating. Yep, streaming it. Yep. So all these forms are using inheritance already. If we look, everything is an object, starts as an object from the system. The system is the main object for everything. That's considered the parent. And then from the parent, we have the system Windows forms, and that's like the next one down. So the system is the parent. The system Windows forms is the child of the system object. And then you have your control. The control has a button base, and then it has the buttons. So you have parent, parent, child. So it kind of breaks down, as we did the HTML, CSS stuff, the same way. You have a parent, then you have a child underneath it. The button base would be considered the parent of the button, the checkbox and the radial button. Group box is a child of the control, label, list control, and then the list control has some children. So it just breaks down with a parent and then children underneath the parent. So here the system Windows forms, you can see the base class. The base class is the parent class. So if you hear base class, that's the parent. You can only have one parent class for inheritance to work properly. So you can see in here they have a string text, a bool minimize box, bool maximize box, and then the void in that. And so when you look down here at the derived class is the child class of the parent. So when you hear base class, that's the parent. The derived class, that's the child. You can have multiple derived classes off a parent, but you can only have one parent class. So just like we have parents, we have 2 parents, but we only get genes from one of them at times. So like Unfortunately, me being bald, I got that from my mom's side of the family, kind of a thing. So just look at it like that, as you got one parent passing something down to you, or another parent passing something down to you. So your parent's passing down to your child, and this works the same way. And we've been using it since we started. If you look at our labs up here, the way they have it, our Form 1 is a child of the form object in this. So that's why every time you look at this, you see this Form 1 : form. It's saying our Form 1 is a child of the form object. And that's kind of how we're going to be working with it these next couple labs, is we're going to set up a parent object or class and then pass it down to a child class or two, depending on what the lab actually is doing. And then the base class has, like I said, the bool minimize box, bool maximize box. If you look at the derived class, it also has the same fields in it. Well, the whole purpose of this inheritance is to reuse code, to make coding easy. So we can take what's in the base class and use it in these derived classes. So if we create a constructor in the base class, we can pass it down to the child and use it in the child class. So like the void close, the void show, we can use those. The toString that we've been overriding this whole time, that is a method of the system object class. It's already coded. It already has a way of wanting to do things. Well, certain methods we can override and tell it we want to do it a different way. So like the toString, we've been doing that already. You can do it with the equals, reference equals, get type, get hash code, finalize, and this memberwise clone. We'll talk about the equals later on, probably tomorrow or the next day, and same with that get hash code and stuff like that. But for now, we've been working with the toString. Today we'll look at this get type, and it talks about the type of class that we're using. So we'll actually print that get type out a couple times in these demos to show what class we're actually using to call this stuff from. So here's like a business product class, or business class for a product maintenance application. And like I said, I don't like these slides that much because they go off of the demo out of the book, and we haven't been following the book like that. But you can see we have the product class up here is the parent, and the line and the arrows going down show both of the children from it. So in that product, the parent class, we have a string code, string description, decimal price, and get display text. The book, they're using the exact same thing, but they add their own little part of the class in there. They do a string author in here, a property. And same with software, they use the same stuff out of the product class, but then they add their own string version property in here. And so you just kind of build off the parent, and you can keep adding to it. So the collections generic list product, so they have a product this, void add, void remove, and they're using the same one. They're using that void add out of it. And they're also using a void fill and a void save. But like I said, these slides aren't that great. But one thing we're going to start using a little bit more in this one is the protected access modifier. And so public, we said, everybody knows it gives access to all the classes, all the program. The private is only available to the current class. Well, now the protected that we're going to start using is available only to the current class or to the derived classes. So that protected can be used with the parent class and down to the derived, the children classes. So we'll start using protected a little bit more just to keep it within the parent and the children classes, child classes, how would you say that, child classes that we go through here in these demos and stuff like that. So you'll start seeing that a little bit more. The syntax for creating a subclass is just the subclass name and then the base class name. So like I showed on here, the form is the derived class, Form 1 is the derived class. The form is the parent class, so the subclass and the base class. Create a constructor that calls a base class constructor, and I'll show you these in this demo coming up, so I'm not going to go too much into them. You do a public class name, put your parameter list in, and then after the parameter list, you put a colon, and then you put the keyword base. When you see that keyword base, that base just means the parent class. So if you see base in your code like that, that's what it means. It's talking about the parent class. So like when we do that two-string override all the time, we always see it say return base dot toText or whatever it says on there. That's what that's saying there, is that it's just calling the parent class, and that parent class for that two-string, of course, is the system object. So that's what it's actually calling there. And so I'm probably going to stop talking about it there and kind of show you. I think it'll be easier to show you some of this and as we go through it and talk about it. So give me a second and I'll get my code set up, and then we'll do a couple demos. Like I said, the demos, the first one's going to be the a letter one, and the second one will be the picture frame or photo frame one, photos. And that will get you going on these two labs in chapter 14 and hopefully make sense with you for inheritance. Yeah, Leon.
Can you go back to this slide where it broke it down from like, I think like systems and then had the other thing and it broke it down? I think it was on the first So like, would the buttons only be able to access button-based things, but it cannot access things that the control has access to?
Yeah, for the most part, seeing their children.
Like one parent,
yeah, going up one like that.
Only access controls, and then controls can always access.
Yeah, so if you looked at it, it'd probably be something like object.control.buttonBase.
Oh, so you call it
dot button. Yeah, so it just shows how it goes down through the hierarchy. So if we look at it technically,
I'm really trying to think like, would button-based be able to access something from object in some like fashion, whether that's calling each individual part. So you get the button-based then call something?
Yeah, I was trying to see if it showed in here a good example of that. I don't think it does. I think the book kind of shows a good example somewhere in it, though. Let me look real quick. Yeah. Let me check in the book, and I'll see what I can find real quick. Windows format, we'll call it letter demo. Got our form, and it says create an application class named letter demo that instantiates objects of two classes named letter and certified letter, and that demonstrates their methods. Classes are used by a company to keep track of letters that they mail to clients. A letter class includes auto-implemented properties for the name of the recipient and the date mailed. Also include a two-string method that overrides the object's class two-string method and returns a string that contains the name of the class using the getType method, and that's one I mentioned earlier, that getType method. That's where we're going to use it here to print out the name of the class and the letter's data field values. Create a child class named certified letter that includes an auto-implemented property that holds a tracking number for the letter. So that's pretty close to what you're going to be doing on your labs for chapter 12, or 14 I should say, sorry. You got your letters, you got your letter class, and you can see on the rubric here, the UML breakdown, they have a system.object. You don't have to code for that. That is always running. That's always in the background. That's always there. That's why we can call this two-string anytime we want to, because this object, the system object, is always running in the background. It's always there for us to use. So we'd never have to code that out. It's one of those freebies that we've been talking about, kind of like when we use the default constructor. It's there, it's running, we just don't see it. But you can see you're gonna, letters 50 cents to send, certified extra 15 cents, send up to 20 letters. Every time a letter is sent, it'll be added to the top of the transition log. And then a couple other things. I'm not going to go all into that. I'm just going to kind of show you how to set up these classes, how to use inheritance in the classes like they want you to use here. Looking at the UML, system object is technically the parent class. Well, then the way we use it, letter would actually be our parent class, our base class. And certified letter comes off of that. So certified letter is the subclass or the child class at that point. And then you can see the pound signs here mean they're protected. The pluses are still public. And then we're going to have a letter with the string, date sent, time, date, time. We're going to override the string. So this is going to be pretty close to what your lab is going to look like. So first thing we'll do is create a class. And that class, it says, is called letter. So add a class, call it letter. Add that. Of course, we always turn it public. So if you look at our rubric again, the way it's set up here, I gotta find it again. The way it's set up, that system object is the parent, then the letter kind of as a subclass. So the way you would code that out if you had to would look something like this. But because we don't have to worry about this object being inherited, our letter being inherited from the object technically, because it's sitting there running in the background and it knows that's what's going on. We don't have to code for that. But we will here in a minute do something with that as we add these classes. So the first thing we got to start out with is our and we're not actually going to use instance fields in this one because I believe it says to create auto-implemented.
So that's what's that for, to stop us from using an instance field?
What's that?
That's what auto-implemented properties.
Auto-implemented properties means all we do is set up the get and set, and when we do that, the instance fields are already running in the background. Yeah, they set it up for us. So these are the properties, and when we do auto-implemented properties, the underscore part of it, the instance fields, they're already created, but they're created in the background. We don't see them. We don't mess with them. And when I first started doing these labs with Mr. G last year, I was doing auto-implemented properties on everything. And yeah, he didn't like that. He's like, start using the underscore. That's how we teach it. Learn how to do it that way. And I'm like, all right. So.
What have you experienced in like the work? Was it?
Yeah, this is how it is kind of a thing. So anything to save time. So I think it said the first thing we need is what, a recipient, name of a recipient, and the date mailed. So we'll do public string recipient. We'll do the get and set for our auto-implemented property. Also use public. And we're going to use date time since we need to get a date. And actually, Drake, I think this might solve your date issue you're having yesterday, trying to get that time off there.
Yeah.
So we'll see if that works here in a bit.
What was it called, time?
Date time, we'll call it date mailed. Or you can call it whatever you want. This is just a variable name. We'll do our get and set for that. We can set a default for it by doing an equal and do date time dot now, meaning it'll get in current date and time for right now, today. And we could also, if we want to, we can set a null default for our recipient by doing it like that. This version, normally you would put a question mark with the string there to say we can let it be.
It could be a string, it might not be a string.
Well, it could be null or not null,
I got you.
but the version we're using doesn't allow us to do that, so we can just put null at the end. But I'm not going to worry about that right now, but we will leave the date time like it is.
What does that do? Daytime dot now.
It just gets the current date and time right now.
Oh, right now.
Yeah, so it's just a default value that we have set.
I'm still wondering how you do it, like between two dates.
Actually, I think I know how.
Okay. So now we says, I think it said we have to do gonna override the string. So we'll do public override string to string. And you can see here it says return base to string. That base is calling the parent, which is the object itself. But we're not going to use that at the moment, so we can get rid of that and just do some string interpolation and say and we're going to use that get type here. So this will tell us the name of our class as we print it out. As a recipient of, and we'll print the recipient out here. And a date mailed of, we're going to call our date mailed property here. And so to get that, a lot of you have been using that date time object in the last labs, and it's putting the time behind it.
Yeah.
A way you can get rid of that is by doing .to short date string. And that's a method. So why is this not happy?
Closing curly.
Did I miss it? Oh yeah, I put a parenthesis instead. There we go. Thank you.
So for the last lab, we put that in our display method.
What's that?
And in the last lab, we put that in our display method.
Yeah, put it there and see if that chops off the time for you. It should chop it off, and we'll see it work here as we run this. So from looking at our thing, we got a application called letter demo. Letter demo instantiates two objects of two classes, one letter and one certified. We got letter done now. It demonstrates our methods. Classes are used by a company. It don't matter. Letter class includes auto-implemented properties for name of recipient and date mail. We got both of those. And a toString method that overrides the toString method. And that's what we got there. So it looks like we have the letter class finished. So now we need another class called certified letter. So add a new class. Certified letter. Make it public. So we want to use that string from the letter class, and we're going to add on to that string from the letter class in our certified letter class. But to show that we are using letter as a parent, we need to go back to where our public class certified letter is. And we need to put a colon and then letter. And that way it allows the program to see that letter is the parent, certified letter is the child. And we're going to use some of the stuff out of the letter class for our certified letter class. So it said we needed a tracking number, so we'll do public string tracking number. And those are auto implemented. And again, we could do the null here if we want to. I never really seen code set up like that very often. A lot of times you'll do a null check as you're doing your gets and sets and stuff like that.
So you're just setting it
to null at the moment, yeah. So that's like a default value. It's just setting it to null. So as we run this, if for some reason it doesn't pick up the tracking number or whatever, it'll come back at null, and then you have to kind of handle the error.
Okay.
And nulls are bad. You don't want nulls. A lot of times they'll crash your program and stuff like that, so you'll have to handle when you have nulls and whatnot. And like I said in the past, when I worked for the Department of Defense, they ran a program that checked for null values that could possibly get through, and you had to set up null checks to make sure you handled any kind of issue that might be caused by them. So now we'll do our public override for the string. It's going to be a toString again. So now we see that return base toString. Well, that return base toString technically is calling this letter toString method here because, as we said, the base is the parent class. We have a toString method in this parent class, and we're going to use it now in our certified letter. And so what we'll do is we want to leave that return base toString there, but we just want to add to it. So we're going to say more string interpolation. So you do a plus. Let me zoom in on this so you guys can see a little bit easier. Plus, and then we'll say the tracking number is, and then put our tracking number in there. So now what this is doing is this return base again, and you can see when we hover over base there, it's saying class letter demo.letter. So it's saying our base class is letter. That's why we have the colon up here with the letter behind it to show that that letter is our parent class, our base class. And even the base down there tells us. Let's look at it on letters and see what it says here. Oh, we took it off. Let's try and see if we can do another one without any issue. Actually. So the base on this one is showing us it's that class system.object. And so that, like I said, that object, system.object is always running in the background. It's there. That's why we can use this toString method all the time. There's a handful of other methods, really more than a handful. There are probably hundreds, if not more, methods that this object, class object, allows us to use. We're not familiar with all of them because we haven't used them all, but toString we've been using a lot. And so you can see hovering over that, it tells us right there, class system.object. And that system.object, system is the parent to everything in this. So go look at our certified letters. Looks like everything is good with that. Got our tracking number, overriding the toString, adding it onto the base. So now we can go to our form. And our not letter, no, because that's the parent. If we really wanted to, we could do colon object, since the object is the parent of the letter.
Do we need to do that?
No, because it's already there, it's running, the program knows that's what's going on with it, so you don't have to worry about that. And then we go to our form. I'm just going to add 2 buttons on this form. Just going to copy this. Button 1. Let's say create letter. Button 2, we're going to say create cert letter. It's our 2 buttons. We're going to go ahead and code out the create letter to start out with. Bless you.
Thank you.
So we'll double click on our create letter, get it wired up. So the first thing we're going to do, and I think it says on our thing, is that instantiates objects of 2 classes, named letter and certified letter. So we're going to go ahead and instantiate an object now. So we'll say letter, since that's a class we're using. And I'll just call it LI. And that's going to equal a new letter. And we're going to go ahead and put data in here now. I'm not using text boxes or anything, so I have to hand feed the data into it. So our recipient class, or our recipient property, I should say, we're just going to say Bob. And then our letter says, I thought it would tell us what we need for it. But looking back at our class, our letter, we need a recipient and a date mailed.
Can you scroll over a little bit to the date mail? Thank you.
Yep. So back to our form, we're going to say recipient as Bob and date mailed. And to put this into a string and have it parse, some of us did it yesterday on some labs. We'll do a date time dot parse. And this parse, you can see here it says converts the string representation of a date and time into its date time equivalent. So then we'll just put today's date in 3/13/2024 and close our parenthesis. Yep.
When we're writing like a date into like a text box when we launch the application, does the date have to be in that specific format, or does that?
I think you can take any format, actually, depending on how you have it. There's ways you can set it up to tell it which format you want to use and stuff like that. You'd have to look more on the date time object to kind of get familiar with it, since we haven't touched it. In that chapter 12 part 2 lab, there's a couple links to talk you through the date time objects and stuff like that.
What if it like the right text box and it doesn't match with its date?
It should match it, because when you parse it, it'll change it into a date time object, so it should match it, as long as you don't get too crazy with how you're putting your date and time in. And even to make sure it doesn't, you can put a little thing in, say this is how you, like, sometimes when you fill out a form, it tells you what format to put your day, month, year thing in, and you can do that just to force them or hopefully have them follow doing that. So there's our letter. And so now we'll go ahead and I got to add a label to my form to have it print out. I'm just going to call this label result. Get rid of the text. And then we'll do label result, text, and we'll do li to string. That's our variable that's holding our objects. We're going to print that out to a string. And of course we overwrote that string, so in our letter class we should see it say something like the get type has a recipient of with the recipient name and the date mailed. Should chop the time and everything off and look decent. So let's go ahead and run that. I got create letter, we'll click on that, and it says the letter demo letter has a recipient of Bob and a date mailed of 3/13/2024. So got what we expected there. That letter demo.letter tells us what class it's using. That namespace is letter demo, and then the class is letter. So that's our create letter there. Any questions or comments, concerns about that? No? All right, so let's go ahead and do our certified letter. So we're going to do it just like we did letter. We're going to use certified letter, call it CI, create and instantiate the object, certified letter. And so if we look at our certified letter class, the only property we have in there is this tracking number. But yet when we run this code, we're going to end up putting a recipient in here. String. Date mailed. And again, we'll do the date time dot parse. We'll go ahead and put today's date in again. And then now we need a tracking number also for this. So we'll do tracking number equals 11223345. You can call it whatever you want for your tracking number. You can put letters in there, you can put symbols in it as long as it's a string. Should be able to handle it. Put my semicolon. So the reason we can set it up like this, the letter class here held the recipient and the date mail properties in it. The reason we can set a recipient and date mailed in our certified letter is because using that colon letter there says we can use different pieces of the letter class that we need for our certified letter. Well, we need the recipient and date mailed out of there, so because of that we can use it in our certified letter when we put values in our constructor there. And then we add the tracking number because the tracking number comes out of that certified letter class. Does that make sense? So then we'll do a label result, we'll do CI to string, and now by doing that CI to string, we type what comes out of, we display what comes out of our letter class, which is going to be the get type recipient. And then it's going to add the tracking number on because we're using the parent class to get the beginning, and then we're using the child class to put the rest of the text on. So if we run that now, it should say letter demo dot certified letter. That's the class we called here. Has a recipient of Joe now and a date. Still has the same date, but now it also shows our tracking number to it. So you can kind of see. Yep.
Damn, it's not working.
Button's not working.
Yeah, but it doesn't.
You got a label down there show the display.
Yeah, there's a label. Did we put like a? Did we do it over sold?
Yep.
Oh, I didn't see it. Didn't see it.
Right there. And if we go back to our certified letter, or back to our regular letter, it's saying that the get type letter dot demo letter, recipient of Bob and mailed. Letter demo certified letter, recipient of Joe and mailed with our tracking number. You got it working?
Yeah.
All right. So you can switch in between. You can go back and change the data inside there if you want to get different names that come up. So if I put Bob's still there, now it says Steve instead, so that will get you started on your letter and certified letter one. Let's go ahead and take like a 10-minute break real quick, and then we'll come back, we'll code out the second one. That'll get you going on your photo one. That one's a little more involved than this one was. We're going to use 2 subclasses, 2 child classes, and use a constructor from the parent class. So
You showed the letter class, like scroll over.
So the next one we're going to do is a photo one. Says here, create an application class named Photo Demo that demonstrates the methods of 3 related classes for a company that develops photographs. Create a class named Photo that includes fields for width and height in inches and properties for each field. Include a protected price field and set it to $3.99 for an 8-inch by 10-inch photo, $5.99 for a 10-inch by 12-inch photo, and $9.99 for any other size because custom cutting is required. The price field requires a get accessor but no set accessor. What's that mean when we only have the get accessor? Read only, that's right. Also include a toString method that returns a string constructed from the return value of the object's get type. So we're going to use that get type again here. And then method and values of the field. Derive 2 subclasses, matted photo and framed photo. The matted photo class includes a string field to hold a color, and the framed photo class includes 2 string fields that hold the frame's material, such as silver, and style, such as modern. Price for a matted photo increases by $10 over the base cost. And when you see that base cost, that means what the cost is in the parent. And the price for the frame photo increases $25 over its base cost. Each subclass should include a toString method that overrides the parent class version. So first thing it said was application name photo demo. So let's do file. I'll just do an add new project. gonna be a Windows Forms app. Call it Photo Demo. Create it. Oh, and I didn't create it where I wanted to. Hang on a second. There we go. Project. I was creating that one in Matt's folder. Photo demo. So the first thing it said is we need class name photo. So let's create a class called photo. Change that to public. And again, technically, our class looks something like that, but of course we don't have to add that object on there because it's already there running in the background. So it says, create a class name photo that includes fields for width and height. Properties for each field include a protected price field. So we're going to put instance fields in this one. We'll do private int width, private int height. And then we're going to use a protected field. It's going to be a decimal since it's a price. And it even knows it wants to be a price. IntelliSense is getting scary smart. If IntelliSense can do that, wait until AI starts getting involved in all these. Then they won't need us to code them anymore.
Taking all our jobs.
Yeah. The AI stuff.
Yeah, it's so smart, it's stupid.
Yeah. So we'll say a private access modifier scopes the members to the class only. So when I say the members here, the members, by the members I mean your instance fields, your properties, your constructors, your methods, that kind of stuff. Public access modifier scopes the members to the entire project. So now we introduce protected scopes the members to both the class and the inherited classes. So when it's protected, it works in that current class that it's in, and for any of the inheriting classes, any of its children, child classes down below.
So when you say inherited, you're basically saying like how we did add letter, certified letter is the inherited.
Yes, yep. It gets the certified letter inherits whatever comes out of that letter class. So just like if somebody passes away and you inherit some of their money, you don't get it all, you get some of it, so you can use some of the stuff over in that. And that's how this works. The children, the child class can inherit different members instance fields, modifiers, all that stuff, it can access those through that inheritance, so it can reuse them. And that's kind of what we're going to show in this one. We're going to create a constructor, pass values into the constructor, and then use them on the child classes, the subclasses. So we're going to create our constructor. And say public photo, and we're going to pass in the width and the height. And we got to assign the width to the width, the height to the height. But we're also going to set our price in here. So we're going to do if width equals 8 and height equals 10. I think that was the base price, wasn't it? Include a protected field and set it to $3.99 for an 8 by 10, $5.99 for a 10 by 12. So 8 by 10. We'll do underscore price equals $3.99. And my code's not happy with me. Anybody know why off the top of their head?
You gotta declare that it's decimal.
Yeah, what do we use for a decimal? Yep. So since we called our price up here a decimal, we have to make it a decimal down here. By making a decimal, we put that letter M behind our value. So then we'll say else if width equals 10 and height equals 12, 10 by 12. Price is going to equal $5.99. And don't forget, when we're comparing something, we use two equal signs to compare it, but if we're assigning something, we just use one equal sign. If you use one equal sign in your if statements, most of the time it's going to break because you can't assign stuff in there. And then finally our else. Let's say anything else is $9.99. So this is going to take a width and a height and pass it down in here. It's going to check if the width is 8 and the height is 10. Set that price to $3.99. Else if the width comes in at 10 and the height comes in at 12, set the price at $5.99. Else anything else is just going to catch it at $9.99. So we need our getters and setters now. We'll do public and width. We're going to return width, but we also need to set our width. Equals the value. Go figure the time IntelliSense doesn't work. Public int height, get return height, there we go. gonna set the height. And this is gonna be read only. Get set properties. Public decimal get return price, that's all we need. Yeah, we don't need that. So then I think the last thing it said is also include a two-string method that returns a string constructed from the return value of the object's get type method and the values of the field. So do public override string two-string. We're going to get rid of the base part because this is the base that we're going to use. And we're going to do that get type again. Has dimension of width. Height. And a price of price. And then price we'll make :C because it's $1. Does everybody understand what's going on here? I'll just create a class called photo, set up our instance fields, got a protected one called price. Our constructor, we're passing in a width and a height. We're going to use that width and height to figure out our price. And then we just do our gets and sets. And I could do it like this if you'd rather more comfortable seeing it this way. So if you're more comfortable seeing it that way, you can set it up that way. And then we're doing our override two-string that we've been doing for the last couple labs. So that looks like all we need for our photo class. Let's see what the other classes are called. Photo, then we need a subclass called matted photo. So we'll add a matted photo.
It's called what?
Matted, M-A-T-T-E-D, matted photo.
You're adding this in the letter, then.
Oh yeah, good call. that. Make this public.
And this is where we would use like the colon, right?
Yep.
It's going out of there. Okay.
So photo is our parent, so we want to call photo here.
Yeah.
Yep. And what's it say when we hover over it?
No art.
There is no argument given that corresponds to the required parameter width and that and photo. So what that's mad about is, yep, in photo we used a constructor in here.
We didn't type the national one, right?
And so because we use it in here, we have to use it in the matted photo class. So we'll get this set up first as soon as I find my matted photo class. So we'll do public matted photo, and we need an int for a width, int for a height, and in this one we are adding a color to it. So we'll do string color. And it's still not happy, and the reason it's not happy is because matted photo doesn't have an int or a height or a width or a height value coming into it. So what you have to do for that, since it's coming out of our photo parent class, we do a colon at the end of our parenthesis on our constructor, and then we call base, and again the base is the parent class, and that parent accepts a width and a height, so we set it up like that instead. So now we use that width and height from the parent class, the width and height here from that parent class in the matted photo class.
It's not a way you could just call it, because we already like put the colon photo, so shouldn't we just be able to access those values from another class?
Not without,
The base?
yeah, the base.
So that's required?
Yes, yeah, you have to have that. If not, it will bark at you. So,
Okay.
so you can see I just commented out, and it's like, hey, the constructor's not matching up.
Mr. G,
Yep.
so what I ended up doing, just out of curious, I went into the photo and I just typed out like the base constructor, like with nothing going through it, and
Yep.
all my errors on matted photo went away.
And you can, but I'm showing you,
Sure.
yeah, how to pass it through. So, because you're going to end up having to do it in these labs.
Okay.
So, yeah, if you don't have anything in the constructor, there's nothing to pass through. So there's nothing to worry about with that.
Okay. I
But
got
yeah, but with passing these through, if they don't match up or you don't call the base when you're using it in the child, it's not going to be happy about it.
I got you.
So,
Okay.
yep. Did you have a question, Liam?
Yeah, so what is the base do? What is its purpose?
It's saying that use the parent class. Base says use the parent
Why
class.
are we using the parent class? I'm just trying to get some.
This is for code reusability, so we don't have to keep typing out all these parameters and all the properties and everything else. They're already done in our parent class, so we're just going to use them out of our parent class now. So if not, we'd have to do like getters and setters on the width and height and everything else all again, and the price and all that. Well, we're not going to worry about that because we're going to use it out of the parent class.
This whole if function, all that code, you don't want us to write again?
Nope, this is why we use this inheritance stuff for code reusability.
Yeah,
So
that's what I'm saying. If you're gonna reuse that, how are you gonna define it? Just by the width and height variables?
if we were going to use it again, yeah, we'd have to do it the same way. But it's already defined. We're already doing it right here in photo, so we're just going to use that part in matted photo, and we're telling it by that colon in photo that we're going to go use that parent class to get some of this stuff out of it.
So it's sort of like a calling a method, low key.
It's calling a method, calling a constructor, and saying use part of the parent constructor in our child constructor. So when a parent class, here's what you're kind of talking about, Matt, has a parameterized constructor. The child class must also have a parameterized constructor. So, like we were just talking, when a constructor has parameters in it, the child has to have parameters in it to pass those values back up into the parent so we can end up using those values.
So Matted Photo is a child of Zoho.
Yes, and that's what this line here is stating, that Matted Photo, the colon in the photo says Matted Photo is a child of the photo class.
Yeah.
So to use that parent class like this, you have to have that colon with the parent class name in it, or it will not work. So if I take that off, you can see the base isn't there, and then if we get rid of the base, which is the only way to fix it, then all that nth, width, and height stuff would be messed up. So then we have to go recode everything. And by just putting that in, though, it saves us from having to do all those gets and sets over again and all that other stuff. So put our values into our constructor. So say color equals color. And then we got to reset the price, I believe it says. So the price for a Matted Photo increases $10 over the base cost. So then we'll have to do something like underscore price equals base dot underscore price plus 10. So now what we're doing here, because we don't get our setter yet. So what we're doing here is we're taking that base price that we created in the parent, and we're saying take that base price from the parent and add $10 to it. So whatever the base price happens to be over here, whether it's $3.99, $5.99, or $9.99, we're saying take one of those prices, whatever it ends up being, and add 10 to it. So then we need our getter and setter for color, and that should make our color in there happy. And then we're going to do our public override string to string, and again here it says return base, Liam. That base means go back to the parent and use the toString method out of the parent.
So like where's it going back?
So use this out of the parent in our Matted Photo, but we're going to add to it and say string interpolation.
How do you specifically get base dot to string to like the override?
When you first type it in, it automatically does it for you because that toString is coming from the parent. The system.object is where that's coming from.
It's not like converting it to a string, though. That's what toString does, right?
Yeah, but it's saying take the object. And so like when we print things back out to the screen, from an int, but we need them to a string. We call that toString method. That toString method's already been coded somewhere back in the system where they keep all the files for the system and all the code for the system. And we just use it from there. We don't have to retype it. We don't do anything. We just call that toString method. Well, we don't want to use it like that now. We're saying we're going to override it and put our own data in there. So when we call it, this is what we want to show up for that toString. So we're going to say a color of color.
Since they know, Mr. G, what the base class is by using this, I think, in my opinion, it would be easier if they just changed it to the name of whatever base class it was. So in our case, photo.toString.
Well, yeah, but because we're using inheritance, that's just the way it works.
Yeah, I get it.
By calling it base instead of like parent or photo. Actually, it'd probably be, would have to do photodemo.photo.toString instead of just typing in base. So it saves a little bit of typing. Plus, you don't have a bunch of different classes being called in there. All you see is base, and
Right.
hopefully know that that's what it's calling. So it looks like that's all we need for this matted photo. So let's go test our stuff real quick and see if it's working. So let's go to our phone design. I'm just going to add a couple buttons. I'll say create photo. I'll just copy this. I'll name it BTN matted photo. Actually, we can go ahead and add our third button if we want. This will be create, what is it, framed? Create framed photo. Everybody chance to catch up with that for a second. Everybody good?
I have an error on, back on my price equals base price.
Okay, let's take a look at it. Click on our create photo button, get that wired up. We'll code that real quick. So we're gonna call our object photo. We'll call it my photo. Gonna instantiate the object by saying new photo. Gonna put some value in it. Gonna say our picture size is 8 by 10. And then we'll print our label out. I gotta put a label on there. Hello. Yes. Give me 1 second. No. I'll stop here. So, gonna name our label. We don't want a value on there or text because we're just gonna print it out. We'll call it LVL result. And then I'll let it was Williams make her speech to you.
No, I need to talk to you.
Oh, me particularly. Okay, well, let me pause the video here real quick.
I
And
just need to tell him everything.
so we got Liam working again. So let's go back, finish up our button click for our create photo. So we'll do label result dot text equals my photo dot toString. So if we run this, it should give us our dimensions and a price. It should be $3.99 since this is just a stock 8x10 photo. So let's give this a run. Make sure everything shows up like it should. Create photo, 8x10 and a price of $3.99, and it's coming from photodemo.photo. So that one looks like it worked all right. And then you can change your values inside here if you want. We'll do a 15x20. Run it. 15x20, and it's $9.99 because anything that's not an 8x10 or 10x12 gets the $9.99 price. So it looks like that's working all right. Everybody's working. That's what I like to hear. So now let's code our matted button and get that out of the way, test that. So our matted photo we're going to do just like photo, but we're going to call it matted photo class. Give it my matted photo variable name. How do we instantiate a new object? What's the keyword? New, yep, new. Matted photo. And this, you can see, by kind of hovering over it there, it says we need a width, a height, and a string color now. So we can do 8, 10. I don't know, let's do orange. Kind of ugly colored picture frame, but we'll put this out to our label result. Text equals my matted photo to string. So if we run that, create matted photo, photo demo.matted photo, that's the class we're calling this from, has dimensions of 8x10, a price of $13.99, and a color of orange. So 8x10 is what? 8x10 is $3.99. We add anything to it, and it's $10 more, so it should be $13.99. That's what we get, $13.99, and it prints out our color of orange with it. Do what?
Can I see the matted photo?
In the- Just like the photo, plus we're just adding the color orange onto it now. Bless you.
Thank you.
Ryan, you coding along or are you on your phone? I said, are you coding along or are you on your phone? All right. Just checking. So you good over there, Liam?
Yep.
All right. So now what do we need? A framed subclass called framed photo. So let's add our class. We'll call it framed photo. Add that. Public And again, we're going to use members out of the parent class photo again, so we have to call photo here. And yes, it's not happy because we need a constructor to make it happy. So we're going to say public frame photo for our constructor. We're going to pass in the values of an int for width, int for height, and then we're going to add a string for the matting and a string for the style. And then we're going to use the base, width, and height. Notice we're not passing a color in on this because matted is not the parent technically of framed. So we're not passing color in, we're only going to pass that width and height that comes from our photo class that we inherit. So up here we'll go ahead and put our instance fields in, and we'll call it public string material, public string style, and then here we'll do material. I'm going to create my getters and setters first just so it doesn't keep switching them on me. So we'll do public string material, get set, but we want, I don't want that way. This is where IntelliSense annoys me. Public string style. There we go. So then we can go back into our down there. Thank you. So now we can go put our values in here. Material equals mat, style equals style, and then we're going to use price again because it says here frame photo increases by $25 over its base cost. So then we'll use price again. Price is going to equal base dot price plus 25. So now what we're doing here is we're going back to our photo class, getting that price from there, whatever it ends up being, and adding $25 to it. Yeah, Dominic. Alright, let me come back there and I'll take a look. So I think that's all we need for this one. So got our frame photo. Frame photo increases by 25. Frame material and style. So it looks like we got both of that.
Don't we need to override the two-string?
Yep, we still need the two-string method. So we'll do public override string two string. And we'll do plus string interpolation, a material of and style of that should be all we need for this one.
Don't want to say how much it's gonna cost?
That will show up from our base.
Oh, right.
So we're still calling our base there. We list our price down in here. So let's run this and see what we get. Oops, I already got a window open, so it's not happy.
Oh, we didn't do it in a format.
Ooh, oh yeah, did we not code it in? I guess we didn't, so that makes sense. I was thinking we did earlier. Yep, so let's go ahead and code that in. Sorry about that. This is pretty much going to be the same way we did the last one. Frame photo. My framed photo equals new framed photo. And we gotta put some values in here, so it's gonna be 8. Looking for a nth of a width, nth of a height, a string of a material, and a string of a style. So we'll do 8 by 10. What kind of material should make it? Mahogany. And then we need a style. We'll call it ultra modern, seeing as wood is so ultra modern nowadays. Oops, I did more than I needed to. Sorry about that. Then we'll print that out to our label. Just equals my frame photo to string. So now let's try and run that. Photo demo frame photo has the dimensions of 8 by 10, a price of $28.99, a material of mahogany, and a style of ultra modern. Looks like I got my N on modern. So you can see, Paul, by just doing that 2 strings that we overrode and it clicks out, it doesn't say anything about the mat or anything like that. It just, yeah, it still picks up your dimensions and the price, but just what we added on to that base there for the style and the material.
Right.
So now if we do create matted photo, it gets rid of the frame photo part of it and just shows that. Create photo just goes to the basic. So that's kind of why that 2 string is nice there, to append it to the base, to, and you'll end up doing that in your lab. So any questions about that, or anything confusing or making you wonder?
My,
Yeah.
I feel like I'll get used to it. I'm still confused right now.
I'll eventually put this out to YouTube, and you can use this as a reference as you're doing these next couple labs. So
something's wrong with my width and height.
All right, well, let's take a look at it. I'll go ahead and stop the video, and I'll eventually push it out to YouTube for you guys.